Okay, so in hypothesis testing part 1, we got an introduction, looked at how to use the tables. Now we're going to take a step further and actually work out the certain values of A for which the probability of X being less than or equal to A is greater than or less than a certain amount. Let's look at the first question, where we've got X is binomially distributed with n equals 20 and p 0.45. So here's our table, 0.45. We want to find the highest value of A for which the probability X is less than or equal to A equals 0.05. So we can see 0.05 lies, 5.3 lies there, where X equals 5. So probability X is less than or equal to 5 is 0.0553, which is greater than 0.05, so we don't want that. So we'll take the next one down, which is 0.0189, and that equals that's less than 0.05. Therefore, the highest value of A is 4. For the next part, you might want to have a go at this. N equals 20, P equals 0.85. So here's N equals 20. Here is 0.05. And there's 0.85 and 0.05. Now the one that lies above it is, so we're looking at this region here, and when X equals 14, we get 0.0673, which is greater than 0.05, so it's not the one we want. When X is less than or equal to 13, the next one down, we get 0.0219, which is less than 0.05. Therefore, A, the highest value of A is 13. Right, let's look at this case. This time we want to look for the lowest value of A for which X is greater than A is less than 0.05. Now what we need to do is flip this around a little by rearranging it. So say we've got X is greater than or equal to A is less than 0.05. We know this is the same as 1 minus the probability X is less than or equal to A minus 1. And that we can leave as 0.05. Now if we rearrange this, we have 1 minus 0.05 is less than the probability X is less than A minus 1. And so what we're effectively looking at is a probability of some value A minus 1, which is greater than 0.95. So if we look at n equals 20 again and 0.45 for part 1, then we come 0.95 we can see lies in the 12, when X equals 12, roughly the X equals 12, 13 region. So if we write that out, we know that when the probability that X is less than or equal to 12 equals 0. Sorry, I beg your pardon, that's the wrong box. We want this one here, 0.942. So probability X is less than or equal to 12 is 0.9420, and the probability X is less than or equal to 13 is 0.9786. So the one where it's greater than 0.95 is 13. So lowest possible value of X equals of, let me just write that again, is for A minus 1 equals 13, and therefore A equals 14. Okay, part 2, or for example part 2, you might want to have a go at this. So we've got n equals 20, 0.85, and you're looking at something which is greater than 0.95, and so we're looking at this region here. And so we've got effectively the same equation. We want the probability where x is less than or equal to a minus 1 is greater than 0.95. And so we have two options. We've got probability x is less than or equal to 18. In fact, it gives us 0.8244. And we also have the probability x is less than or equal to 19 equals 0.9612, which is the one we want because it's above 0.95. Therefore, we can conclude the lowest possible value of a minus 1 equals 19, and so the lowest possible value of a equals 20. Okay, in hypothesis testing part 1, we looked at this question and we solved it in terms of probabilities. What we now want to do is actually work out the exact critical value and the critical region, because this does come up in exams as well, and then use that as a basis to decide whether we accept or reject the null hypothesis. So let's go back